Hello! In this video, we're going to use Python to do some calculation and analysis related to projectile motion. So we want to write a program that returns the travel time, maximum height, and horizontal range of a projectile, and then plots the travel path for the projectile when we input the initial height, velocity, and angle for the projectile. It's a good idea to write pseudocode or sort of map out your code as you're starting a problem like this. Since we're doing some math and some graphing, we're going to need to import some modules. So that'll be the first bit we do. Next, we're going to need to get our variables from the user. We're also going to need to do some calculations to get our outputs. We're going to want to print the outputs that the user wants. And then we're going to want to plot the data. So these are sort of the 5 chunks we're going to need. I'm going to skip the import module parts for now, and we'll come back and import modules as we need them. It's a good idea to do that so that your program doesn't get too bloated with unnecessary modules. Alright, so we're going to want to ask the user for the initial height, the velocity, and the angle of the projectile. I'm going to call the initial height h_0 or h0 if you were writing it down. We're going to use the eval input functions. Input takes an input from a user, and eval takes that input and turns it into a number. So if you wanted to input a string, you wouldn't use eval. Input, we can write what we want the prompt to say. So I'm going to say, please enter the starting height in meters. And then I'm going to make a comment over here that just says meters, so we are keeping track of our units correctly. We're going to ask for the initial velocity, so I'm going to call that v0. And it's going to be the same, so I'm actually just going to copy this line of code. And this is going to be the starting velocity. This is actually speed, right? Because we're not asking for the direction. So starting speed in meters per second. And then we're going to want the angle. I'm going to call it theta. And then we can copy and paste this again. I think I have too many parentheses there. Okay. Input the starting angle in. We'll ask for the angle in degrees. Okay. Let's move on to our calculations. We're going to want to find the travel time, maximum height, and horizontal range. So I'm going to call the travel time t final. Final time when the projectile lands. And from physics, the calculation for that, the formula for that is what you see on your screen. And so we're going to do 2 times the initial speed times the sine of the angle. And then we need to divide that by g, which is the acceleration due to gravity. Now, Spider's going to warn us that we have 2 undefined terms here. We have sin undefined, or sine, and we have g undefined. So let's define g ourselves as a global variable, and we're just going to say that it's 9.81, and I'll leave a comment that that is meters per second squared. To get the sine function, we're not going to write our own function, we're going to import that from math. So from math, import sine. And when you use Spider here, it'll give you some suggestions of functions to import from the module. So sine is here and hyperbolic sine, so I'm importing sine. Okay, everything is good and dandy there. So now we need hmax. And the formula for that is on your screen as well. And so that is initial velocity times sine theta. And then that whole quantity is squared. And we're going to divide that by 2 times g. So really important grouping your terms here when we are writing mathematical formulas out. And finally, we have I'm going to call the horizontal range that we're going to calculate. And that is given by the initial velocity, the initial speed, squared, times sine of 2 theta and that is divided by gravity. Let me just make my code a little bit consistent there. Okay, so let's leave a little note about each of these in case we are looking at this later. And so this is total travel time in seconds. This line is the maximum height of the projectile in meters. And the last one is the maximum range of projectile in meters. Okay. So that is the calculations we need to do. Now we need to print the outputs. And so I'm just going to use the print command, print function. And I'm going to have it say the total time is. And so the print function can take several arguments separated by commas, and it will just print them all right in a row on the same line. So we're going to say the total time is t final. So I'm going to use the variable there. And then I'm going to say seconds, period. So when we print that, that'll all print on the same line together, and it'll look like it's all a sentence. And then we're going to do that for all of these. So the maximum height is hmax meters. And then lastly, we will print the horizontal range is meters. Okay, let's not worry about plotting the data right now. Let's just run the program and see if we run into any issues. So when I run it over in my console, I will see Spider asking me for the input. So it says please enter the starting height in meters. So let's start at, let's just go ahead and start at 0 meters. Let's pick a starting speed of 50 and a starting angle of 45 degrees. Okay, so it prints it out here, but it also prints it out up here in our variable explorer, which is kind of cool. So it says the total time is 8 seconds, the maximum height is 92 meters, and the horizontal range is 227 meters. These decimals are kind of long and annoying, so let's change that, and we can change that by using the round function. And I don't want to round it up here. I don't want to round it in my calculations. I just want to round the output that gets printed. So round, you put the thing you want to round, comma, how many places you want to round it to. So I'm going to round to 2 places. Let's do that for all of these. That way we don't lose any precision in the calculation, but the output is much nicer to read. Okay, let's run it again. Let's see what happens. Let's do a check here on ourselves, and let's fire it, our projectile straight up, and see what happens. So let's do 90 degrees, just to make sure, you know, we can kind of estimate what the output should be. Like the horizontal range should be 0 if we fire it straight up. Okay, so the total time is 9 seconds, the maximum height is 101.84 meters, the horizontal range is negative 217 meters, so this is obviously incorrect because we fired the projectile at 90 degrees. So the problem here, if you want to take a second and pause the video and figure it out yourself, I invite you to do that. The problem is actually in our sine function. And if you were to look at the documentation on sine, or if you were to read the prompt here for sine, let's see if I can get the prompt to come up. Yeah, so sine returns the sine of x measured in radians. So the argument you need to put in here needs to be in radians, and ours is in degrees. So the way that we can fix that is by going up here and recalculating theta. We're going to say theta equals radians of theta. Now radians isn't imported, but the math library has a function called radians that converts an angle from x degrees to radians. So that should fix our problems. Let's try to run it again and see what happens. We'll do the same thing. 0, 50, 90. And now the horizontal range is 0 meters like we would expect. And these numbers, while they didn't look bad before, we can be a little more certain that they are correct now. Okay, let's move on to the last part of our task, which is plotting the data. So this is going to use some libraries that you may not have used before, and but we have to import them because plotting is not native to Python. So we're going to import, I'm going to import matplotlib.pyplot. So I'm importing just part of matplotlib here, and I'm going to import it as PLT, so it's a little bit shorter to use. And I'm also going to import numpy, which is going to help us make some points in our graph. All right, so let's work on plotting the data. So the x value for the data, if we're plotting the trajectory of this, the x value is given by the velocity, which is v naught, times the cosine of the angle. So this is the velocity in the x direction, times the time. So we'll need to import cosine, since it's not one of the functions that we have imported. And then the y position at any given time is given by the initial speed times sine theta times t minus 1/2 times the acceleration times t squared. The acceleration is g times t squared. Half of that is just divided by 2. So these are parametric equations that will graph the parabola. And the error I'm getting here is that I haven't defined t. I haven't defined the time. So we want to graph this for t equals, I'm going to use np.linspace here. And what this function does is it creates an array of numbers from wherever you tell it to start. So we're going to start at time equals 0 to wherever you tell it to end. We're going to end at t final. And then you can tell it how many numbers to generate evenly spaced between those two things. I'm just going to pick 1,000 so we get a nice smooth curve. So this generates 1,000 points between 0 and the final time. Okay. The last thing I need to do here is I'm going to just clump those back up. I need to tell matplotlib to actually plot the graph. So I'm going to define these two variables, fig and ax, as plt.subplots. And what this piece of code does is it generates the space, the actual graph that our plot is going to be put on. So this generates the plotting space. And then the method ax.plot, or the function ax.plot, actually plots my two variables against each other, so x and y. So this puts the points on the graph. Okay, so let's go ahead and run it. And let's just do something like we start at 0 meters, 50 meters per second, let's say 45 degrees. Okay, and so here's my output for that, and here's my variable explorer. If you want to actually see the plot, you need to go to the plots tab right here, and you'll see the graph. And it's not labeled or anything. There are some more methods and functions in these libraries you can use to label your axes and your title of your graph and a legend if you want. We're not going to cover that in this video, but you can see that the graph has been plotted, starts at 0, 0, it goes to our final horizontal range, and the maximum height is 63, which appears to be about correct there. Okay, so that's a little bit about problem solving in Python. Thanks for watching, and I'll see you in the next video.